All right, I'm going to go ahead and go over this practice problem right now. If you're right in the midst of plotting some data and doing some lab work, you can stay focused on that. Don't worry. I'll record this and upload it to YouTube so you can watch it at your leisure later. It reads, this is actually question 13 from ACE Physics Syllabus Code 9702, paper 13 from October, November 2012. It reads, the Icaros satellite has mass 320 kilograms and moves through space using a solar sail of area 20 meters squared. The average solar wind pressure is 1.0 by 10 to the negative 5 newtons per square meter. What is the acceleration of the satellite caused by the solar wind? The reason why this is a helpful question to sort of practice with is because it helps develop a strategy of letting the units sort of guide your thinking here. So we kind of know if we're solving for acceleration, we're given pressure. Acceleration is related to force by Newton's second law, right? F equals ma. They give us the mass, they ask about the acceleration. So you're kind of thinking about, well, if I could get the force, I could use Newton's second law, F equals ma, and solve for A. But we're not given a force, but rather a pressure. So let's sort of begin with this idea. Pressure is force per area. And they tell us that the solar wind pressure, so the sun creates this pressure from the solar wind as it sort of pushes out into space. And that pressure is 1.0 by 10 to the negative 5 newtons for every square meter, right? Newtons per square meter, that's pascals of pressure. Let the units help guide your thinking. What we want is the force, not so much the pressure, but the force. Well, this spacecraft has a sail with an area of 20 square meters. So imagine this giant sail that's able to collect all of this solar wind pressure. All right, all of the solar wind that sort of crashes into the sail exerts a force on it, right? It's a force per area, pressure. Multiply this by the area and we'll cancel out meters squared. So we have a solar sail with an area of 20 meters squared. When we multiply these two, like we're saying, there's this many newtons of force acting on each square meter, but I've got a solar sail that has 20 square meters, right? So how much total force am I going to sort of collect from my solar sail? It's the product of these two numbers. So my calculator, I can take 1 times 10 to the negative 5, multiply it by 20. That gives me a force of 2.0 by 10 to the negative 4 newtons. And Newton's second law, remember, is F equals ma. So this is the net force now acting on my spacecraft. The spacecraft was 320 kilograms. And so I can divide each side by mass here to make A the subject. And so acceleration would just be force divided by mass. The force was 2.0 by 10 to the negative 4 newtons. The mass, 320 kilograms, right, was given. And so I have that force in my calculator divided by 320 to give me an acceleration of 6.25 by 10 to the negative 7 meters per second squared. Remember that a Newton is a kilogram meter per second squared, so the kilograms would cancel. I'd be left with the correct units of acceleration, and I would choose choice B because that's the correct level of significance. Uh-oh, let me autofocus that. There you go.